In this lesson, we're going to cover something called quotient rule for derivatives. So quotient rule is simply whenever you are given a quotient function, that is a function divided by another function, and you need to find its derivative. So just like with power functions, composite functions, and product functions, there's specific rules that cover those types of functions for derivatives. So similarly, if we have a function divided by another function, we're going to need to use a specific rule called quotient rule. So this is whenever you have a function like q of x equals f of x over g of x, or we could call it u and v. So q of x equals u divided by v. So some cases listed below is maybe we have a function that looks like f of x equals x squared minus 6x plus 2. What you have is a polynomial divided by the radical function square root of x. G of x is sine x divided by 1 minus x to the negative second power. So clearly what you have is a trig function divided by some other kind of weird looking function. So the rule itself, though, says if q of x is equal to f of x divided by g of x, the derivative q prime of x is f prime of x times g of x minus g prime of x times f of x divided by g of x quantity squared. Or if you want to think of the top as being u and the bottom being v, then q prime of x is u prime v minus v prime u all over v squared. And it's very important to keep in mind that the top function has to be u and the bottom function has to be v. Unlike product rule where the order didn't matter, whenever you're dividing, the order does matter. So let's look at a quick example. If I have f of x equals x squared divided by 1 minus the square root of x, whenever I go to take the derivative, I first want to identify the function on top, and we'll call it u. So let's take u equals x squared, and v equals 1 minus square root of x, or we could call it x to the 1/2 power. When I take the derivative of u, I get u prime. U prime is equal to 2x. V prime is equal to negative 1/2 x to the negative 1/2 power. So remember, the derivative of 1 is 0, so the 1 won't show up. Then I have my negative sign, so I bring the power down and then subtract 1 from the exponent. So whenever I put it all together, my derivative f prime of x is going to be u prime times v minus v prime times u all over v squared. So putting that together, I'm just going to replace v, v prime, u, and u prime with what they're equal to. So in this case, u prime is 2x, v is 1 minus x to the 1/2 power, minus v prime, which is negative 1/2 x to the negative 1/2 power, times, in this case I have u, which is just x squared. All of that has to be divided by v, which is 1 minus x to the 1/2 power, and I need to square that quantity, and that's my derivative. It's very ugly looking, but this is what quotient rule does. It allows us to find derivatives of quotient functions. So of course I could simplify this if I wanted to, but for the sake of time, we're not going to do that right now. Let's take another example here. Say I have the cube root of x minus 1 divided by x, and I wanted to find that using quotient rules. So I could say f prime of x is equal to u prime times v minus v prime times u all over v squared. So if I replace the top as u and the bottom as v, u prime is going to be 1/3 x minus 1 to the negative 2/3 power, and then that's going to be multiplied by v, which is x, minus v prime is 1, and 1 is going to be multiplied by the cube root of x minus 1. All of that is by v squared, so in this case just x squared. So this is my answer using quotient rule. I could find the same answer using product rule, it's just going to look a little bit differently. So remember, if I have f prime of x over here, product rule is u prime times v plus v prime times u. So if you're uncomfortable with quotient rule and you'd rather use a product, you can change your quotient to a product by simply bringing the denominator up to the top and making its exponent negative. So I'm just moving x up to the numerator, making the exponent -1, like I see here. All right, so I replace u prime, v, and v prime, so f prime of x by product rule is going to give me 1/3 x minus 1 to the negative 2/3 power, times v, which is x to the negative first, plus v prime is negative 1, x to the negative 2, and then that's times u, which in this case is cube root of x minus 1. So while my answer looks a little different than what I have on the other side, this in fact is actually the equivalent answer. It's just one is using quotient rule, the other is using product rule. So anytime you encounter a quotient function, if you're uncomfortable with u prime v minus v prime u all over v squared, feel free to use the product rule. Just make the necessary manipulations to your function.